The DIAG for Bike diagnostic system also provides tools for optimizing the fuel maps of the electronic fuel injection system. The general term for this and similar process is tuning. The process of tuning, in most cases, is to set performance parameters as high as possible, regardless of the emission behavior of the engine or the economy of operation. That, however, is not the main goal of the DIAG for Bike system. Let's explain, in simplified terms, how it all works in a motorcycle. The demands placed on a motorcycle engine by various regulations and by bikers are contradictory. A forced goal is to produce as little noise and emission as possible. However, technical measures that allow this limit the intake of air. This decreases the achievable performance parameters. The motorcycle manufacturer is forced to build motorcycles that meet strict regulations, primarily in terms of noise and emissions. This is achieved through various technical solutions such as installing silencers and catalytic converters in the exhaust, mounting efficient intake filters, and using sensors that evaluate combustion, for example oxygen sensors. The fuel maps of the fuel injection unit are then adapted to this configuration of engine accessories. Fuel maps describe how much air a given engine construction is able to supply to the combustion chamber of the cylinder and how much fuel needs to be added. The result of the actual combustion process is then monitored and regulated to a limited extent by an oxygen sensor built into the exhaust. The oxygen sensor thus corrects the real air-fuel ratio of the combustion process in relation to the type of fuel used, changes in the motorcycle caused by production tolerances, wear on individual engine components, and its accessories, etc. The goal is for the engine to operate in defined map areas at the stoichiometric ratio. It is a ratio where fuel is used most optimally. These specific fuel map areas should primarily cover modes the engine runs in while in city traffic. The stoichiometric air-fuel ratio is a ratio where the engine has minimal emissions and operates at more or less minimal fuel consumption. Maintaining the stoichiometric ratio in these areas is also important for proper functioning of the catalytic converter, which is then able to nearly eliminate the engine's already low emissions. With this, we have described the design of a motorcycle as it comes out of a factory. For most owners, this factory design will quickly become unsatisfactory. This is where motorcycle modifications come in. There are several reasons to make modifications or adjustments such as the design of the motorcycle, the sound of the engine, or performance parameters. Here we will focus only on those parts and components that affect the functioning of the engine. These are primarily the exhaust and its built-in silencer, and intake components, in other words, intake filter and its box. Other engine modifications representing changes in displacement, compression ratio, and valve timing are in most countries exclusively reserved for racing motorcycles. Before we get into more details, we must first explain individual levels of modification. Level 0 represents a motorcycle in its original state, without any modifications. Level 1 represents the installation of an open intake, in other words, a filter with reduced air resistance, or an open exhaust. Level 2 represents the installation of both an open intake and an open exhaust. Level 3 represents the installation of an open intake and an open exhaust while also replacing the camshafts, which can change the timing of valves. Other levels of modification, level 4+, are beyond the scope of this general training and are intended exclusively for racing anyways. However, level 1 to 3 modifications are relatively common, which is why we will take a look at them in greater detail. How do these modifications affect the behavior of the engine? First, the sound of the motorcycle. The owner generally appreciates a deep purring sound. Second, performance parameters. In most cases, reality is far behind expectations. Promised increases in performance parameters in the order of dozens of % after modification are nowhere to be seen when driving. Third, driving comfort. In many cases, driving comfort actually becomes worse due to the performance delays or even a drop in performance in certain areas. Sometimes the engines running may even become unstable in certain isolated areas of performance. That becomes particularly unpleasant if these areas are commonly used in city traffic. A frequent example is a Sportster motorcycle with Level 2+ modifications. Fourth, functioning and reliability of the engine. The owner notices increased engine temperatures and often even increased exhaust temperatures accompanied by changes in the color of parts of the exhaust. Fifth, unpleasant acoustic phenomena. Afterfires often start appearing during or after deceleration. How is it possible that modifications have only achieved a positive outcome in one respect, but all remaining aspects are negative? The answer is simple and logical. As mentioned before, fuel maps of the fuel injection unit are set to fit the factory configuration of engine accessories: exhaust, intake, valve timing, etc. The capability of individual engine cylinders to take in air is described by VE maps. VE means volumetric efficiency. These maps will be described in more detail later. What's important for now is that these are tailored to the factory configuration of the engine. Modifications to the exhaust and intake have major influence on the engine's ability to take in air for combustion. In many cases, these modifications even help improve the actual VE maps of the engine cylinders. This creates the right conditions for increasing performance parameters as well. The problem is the EFI control unit does not know that. The EFI control unit is still creating a fuel mixture for a standard engine without modifications. That means the engine often works with a lean mixture, and the extra air that the engine takes in isn't made use of at all. The lean mixture the engine ends up working with is then the cause for the majority of the negatives mentioned earlier: unstable performance, overheating, afterfires, decreased driving comfort, etc. That is where tuning with diag for bike comes in. The goal is to remedy the situation and set the VE maps in the control unit so that they correspond to the real configuration of the newly installed components in the motorcycle. Setting correct VE maps brings the engine's behavior back in order and eliminates the majority of the problems that began once the new modifications were made. The emissions behavior of the engine also turns back to optimal levels. The end result is a comfortable, stable motorcycle that you can make full use of the newly installed accessories while maintaining low emissions.